Welcome back to the deep dive. Today we're jumping into VMware Workstation Pro. It's pretty much the gold standard for running virtual machines on your desktop.
Absolutely. And we've got this really detailed hands-on tutorial as our source material. Our mission today, give you the professional shortcut, cut through the noise.
So we're assuming you know the basics, right? A virtual machine, a VM, is like having a computer inside your computer. Lets you run multiple operating systems on one machine.
Exactly. No rebooting needed. But VMware Workstation Pro, it took that idea and made it high performance, stable. It's what people use for serious development, testing new software safely in a sandbox, or just learning different OSes.
Okay, let's get practical. Before you even think about installing it, what are the non-negotiables, the system requirements?
Right. Prep is everything here. First off, you need a 64-bit by 86 processor, Intel or AMD, doesn't matter which brand.
And the crucial bit, the one people sometimes miss.
Yes, the BIOS setting. Or UEFI on newer machines. You must enable the hardware virtualization features. That's Intel VTX or AMD V. It has to be switched on.
Why is that so critical? Like, what happens if it's off?
Well, if it's off, VMware has to emulate the CPU instructions instead of using the chip's built-in features, and the performance just tanks. We're talking like maybe 10% of the speed you should be getting.
Ouch. Okay, so unusable for anything serious.
Totally unusable for professional work, yeah.
Yeah.
You're basically relying on those hardware hooks for near-native speed.
Makes sense. Don't emulate if you can execute directly. Okay, beyond the CPU, RAM storage. What's the story there?
Minimum RAM is listed as 4 GB. But honestly, for any real work, you want 8 GB or more. Seriously.
Why so much?
Because each VM needs its own slice of RAM. And your main operating system, your host, still needs its own memory, probably 4 GB just for itself to run smoothly, so it adds up fast.
Right. And storage.
The VMware install itself is small, like 2 GB. But the VMs, they need disk space. Planned for maybe 20 GB for a light Linux VM, but 50 GB or more for something like Windows 10 or 11.
Okay, now let's talk about the potential roadblocks, the installation killers. You mentioned modern Windows has features that can clash.
This is probably the biggest headache people run into. Conflict avoidance is key. Before you install VMware Workstation Pro, you absolutely have to disable any other hypervisors running at the kernel level.
Like what specifically?
Things like Microsoft Hyper-V, the Windows Sandbox, even WSL2, the Windows subsystem for Linux version 2, they all use the underlying Windows hypervisor platform.
And if those are active, they grab those hardware virtualization features we just talked about.
Exactly. They take exclusive control, locking VMware out. So you need to go into turn Windows features on or off in the control panel of settings and untick all of those.
Is that it?
Almost. There's also a setting called memory integrity, sometimes called core isolation in Windows security. You need to disable that too.
And then you have to reboot, right?
Yep. A system restart is mandatory after turning all that off. It ensures VMware gets that clean, exclusive access to the hardware it needs to perform well.
Okay, so system prepped, potential conflicts removed, restarted. Installation itself seems easy enough. Download from the site, run as admin. But let's talk cost. Value. A lot of people use VirtualBox because, well, it's free. VMware Workstation Pro usually costs around $199 for a standard license. Is it really worth it? Is it just about, like, better 3D graphics?
That's a fair question. And they do offer a 30-day free trial, so you can test everything. They also have academic pricing, which helps.
But for professionals?
Professionals often pay for the stability and performance. VMware is engineered for heavy sustained workloads, running multiple complex VMs for days or weeks without crashing. That reliability saves time, which saves money.
So it's less downtime, less troubleshooting compared to maybe free options?
Often, yes. Plus, you get more advanced features, better performance tuning, more sophisticated virtual networking, really robust snapshot management. For pros, these things often justify the cost pretty quickly.
Okay, installed. We open it up. Standard layout, right? VM library on the left, main content area on the right.
Yep, pretty intuitive interface.
What's the first piece of advice for setting up your workspace for optimal performance?
Change the default VM location. Straight away. Don't let it save those huge virtual machine files in your standard documents folder, especially if that's on your main OS drive.
Why not?
Performance. VM speed relies heavily on how fast it can read and write to its virtual disk. Putting those files on a separate fast SSD or even just a different partition makes a massive difference. Boot times, opening apps inside the VM, everything feels snappier.
Got it. Faster drive for the VM files. Now, Virtual networking, this sounds complicated, but it dictates how the VM connects to anything else.
That's a core concept, yeah. And you need to pick the right type for what you want to achieve. There are 3 main ones.
Let's start with the default, the one most people probably use without thinking.
That would be NAT, Network Address Translation. The VM essentially hides behind your host computer, sharing its IP address. It uses your host like a little router.
Good for it.
Just general internet access, browsing, updates. It's simple, keeps the VM somewhat separate, and doesn't use up extra IP addresses on your network.
But what if I'm setting up, say, a web server in the VM or a game server, something other machines on my home network need to connect to? NAT won't work then, will it?
Nope, NAT hides it. That's exactly where bridged networking comes in. You switch it to bridged.
And then what happens?
Then the VM acts like a completely separate physical device on your network. It gets its own unique IP address from your main router, just like your laptop or your phone does.
So it's fully visible, fully accessible on the local network.
Precisely. Use bridged when your VM needs to be a proper server or needs direct communication with other physical devices on your LAN.
Okay, that makes sense. And the third type, the one for maximum security.
That's host only. This creates a completely private, isolated network. It only connects the host computer and any VMs you put on that same host-only network.
No internet access, no connection to the wider physical network.
None whatsoever. It's totally sealed off. Perfect for security testing, like if you want to examine a suspicious file without any risk of it reaching out to the internet or other machines. Maximum isolation.
Excellent. Okay, so we've prepped the system, installed VMware, configured the network settings. Now we're actually building a VM. We use the wizard, pick the OS Windows, Linux, maybe even older stuff.
Right, and the wizard guides you. But then comes resource allocation. Again, super critical for performance.
We touched on RAM and disk space minimums earlier. Let's refine those for real-world use.
Okay, for Windows 10 or Windows 11 VM, I'd say at least 4 GB of RAM, maybe more if you're doing heavy work inside it. And 50 GB of disk space is a safer starting point than the absolute minimum.
And for Linux.
Depends hugely on the distribution, of course.
Yeah.
But for many common desktop or server Linux distros, maybe 2 GB of RAM and 20, 30 GB of disk space is often enough to get started.
What about processor cores? The wizard suggests a number, but how do we choose wisely?
Yeah, don't just max it out thinking more is always better. Over-allocating cores can actually hurt performance because it starves your host OS.
Yeah.
Under-allocating obviously makes the VM sluggish.
So the sweet spot.
For general desktop use, maybe running some Office apps or browsing, 2 cores is often plenty efficient. If you're doing something demanding inside the VM, like software development, compiling code, running databases, then maybe 4 cores, or possibly more, might be justified.
Best advice is probably start smaller, like 2 cores, and only increase if you actually see the CPU as bottlenecking things inside the VM.
Exactly. Monitor performance, then adjust. Don't waste resources unnecessarily.
Okay, fast forward. We've installed the guest operating system Windows, let's say, but the screen resolution is stuck at something tiny, like 800 by 600, and the mouse feels weird, like you have to click inside the window to use it and hit Ctrl plus Alt to get it back out.
Yes, the classic post-install experience. That's your cue for the next absolutely crucial step, installing VMware tools.
This isn't just an optional add-on then.
No, not at all. It's vital. Mandatory, really, for a usable experience.
Yeah.
Without VMware tools, the VM is running on very basic generic drivers for graphics, mouse, networking, everything.
So what magic does VMware tools perform once installed?
It's like night and day. It installs optimized drivers inside the guest OS. Suddenly, your display resolution adjusts dynamically as you resize the window. Your mouse moves seamlessly between the host desktop and the VM window without any clicks or key presses.
What else?
You get shared clipboards copy on the host, paste in the guest, and vice versa. File sharing becomes easier, usually drag and drop. Time synchronization between guest and host. It just makes the VM integrate smoothly.
How do you install it? Is it tricky?
Usually very easy. There's a menu option in Workstation like Install VMware Tools. It mounts a virtual CD inside the guest OS. On Windows, it typically auto-runs an installer. On Linux, you might need to manually mount the CD, extract a tarball, and run an installation script from the terminal. But it's well documented.
Okay, VM built, OS installed, VMware tools making it smooth. Now I need to manage this thing effectively. Let's talk about save points.
Snapshots. Yeah, this is one of Workstation Pro's killer features. A snapshot captures the entire state of the VM at a specific moment in time.
Meaning what exactly?
Memory.
Disk.
Everything.
Yeah.
The contents of its RAM, all running processes, its settings, the exact state of its virtual hard disk. It's like freezing it perfectly in time.
And the main use cases.
Safety. Before you install some dodgy software you downloaded, or before you make a major configuration change or apply a big Windows update inside the VM, take a snapshot. If anything goes wrong, breaks the VM.
You just revert.
Just revert back to the snapshot state instantly. Boom. Like it never happened.
Yeah.
Invaluable for testing and development.
But there's a catch, right? They aren't backups.
Correct. Huge caveat. Snapshots are temporary safety nets, not long-term backups. They work by freezing the original virtual disk and recording all subsequent changes into separate Delta files.
Which means
they consume extra disk space, sometimes a lot. And having many snapshots, or very old ones, can eventually start to degrade VM performance slightly.
So use them for short-term protection. Then once you're happy with the changes, you should delete the snapshot.
Exactly. Either revert if it went wrong, or commit the changes, which merges the Delta file back into the main virtual disk, and delete the snapshot to reclaim space and keep performance optimal. Don't rely on them for disaster recovery. Use proper backups for that.
Good distinction. Now, quickly, the power controls for a VM. Suspend, shut down guest, power off. They sound similar, but they're quite different from a physical PC.
Very different consequences, yeah. Suspend is like putting your laptop to sleep. It saves the VM's current running state, RAM contents and all, to a file on the host's disk, then pauses the VM, freeing up the RAM it was using. Quick to pause, quick to resume later.
Okay, what about shutdown guest?
That sends the standard shutdown command into the VM's operating system, like clicking Start Shutdown in Windows. It's a clean, orderly way to power down the VM, ensuring all files are saved, services stopped properly. This is the preferred method.
And power off sounds ominous.
It is. Power off is the equivalent of pulling the power cord out of a physical computer. It just kills the VM process instantly. You should only use this if the guest OS is completely frozen and unresponsive.
Because it risks data loss or corruption.
Absolutely. Just like yanking the plug on a real PC, always try shutdown guest first. Use power off as a last resort.
Okay, so we've built it, configured it, optimized it, learned how to manage snapshots and power states. Let's bring it home for the listener. How can they apply this right now? Give us some practical project ideas.
Okay, two great ones. First, the clean room. Build a dedicated VM, maybe Windows or Linux, specifically for testing potentially risky stuff.
Like opening weird email attachments or running downloaded programs you're unsure about.
Exactly. Install the OS, maybe update it, install VMware tools, then take a clean snapshot. That's your baseline. Then drag the suspicious file into the VM, run it, see what happens.
And if it turns out to be malware?
Doesn't matter. It's contained within the VM. Once you're done testing, just revert to that clean snapshot. Poof, all traces of the malware are gone. The VM is instantly back to its clean state, ready for the next test.
And for maximum safety with this clean room VM, which network settings should we use?
Good point. Definitely use host-only networking for this. That guarantees that even if the malware tries to phone home or spread across your network, it can't. It's trapped inside that isolated virtual network with no path out.
Brilliant. Total isolation. What's the second project idea? Something maybe a bit more complex?
The Learning Lab. This leverages the fact that Workstation Pro can run multiple VMs simultaneously, assuming your host has enough resources, especially RAM.
So you could build a mini network.
Precisely. Imagine you want to learn Windows Server administration. You could set up one VM as a Windows Server domain controller, a second VM running Linux acting as a web server, and maybe a third VM as a standard Windows 10 client machine.
And connect them all together.
Yep. You could put them all on the same bridge network so they get IPs from your router, or maybe put them on a host-only network to create a totally self-contained lab environment. Then you can practice joining the client to the domain, configuring group policies, setting up web services, troubleshooting network issues, all on your own laptop.
Without needing a rack full of expensive physical servers, that kind of hands-on practice must be invaluable for learning or certification prep.
Absolutely. And the beauty is, if you mess something up configuring the server, just revert to a snapshot. It dramatically speeds up the learning process because you're not afraid to experiment and break things.
Okay, wrapping up then. Key takeaways. VMware Workstation Pro is really about performance, stability, and control. It gives you that flexibility for learning, development, testing, all within a safe, manageable environment.
Yeah, the networking options give you precise control, the resource allocation lets you tune performance, and snapshots are just lifesavers for testing and quick recovery.
And looking at the bigger picture, where do these skills lead?
Well, mastering desktop virtualization like this, especially understanding the resource management, the networking concepts like NAT versus bridged, it directly lays the foundation for understanding enterprise-level virtualization. Platforms like VMware vSphere, which power huge data centers and cloud infrastructure.
So these skills are transferable to really in-demand areas.
Definitely. It all starts with these core concepts you practice right here on your desktop.
It really circles back to planning, doesn't it? Especially around resources.
It does. And memory is almost always the first bottleneck when you start running multiple VMs. So here's a final thought for you. Consider that learning lab scenario, a Windows Server VM needing maybe 4 GB RAM, a Windows 10 client needing another 4 GB, and a basic Linux VM needing 2 GB. That's 10 GB just for the guests.
Plus, your host OS needs its own RAM, say another 4 GB minimum.
Right. So you're looking at needing at least 14 GB of physical RAM in your machine just to run that relatively simple lab comfortably. So the question for you is, how does your current system stack up against those kinds of multi-VM requirements? And if you were going to build your ultimate VM lab, what would be the very first hardware upgrade you'd make?